Okay, so it's Maths Revision, grade 12, and we're looking at these four concepts quickly. So for X, which is question 1, number patterns, which is question 2 and 3, functions, you will then find in question 4, 5, and 6. Calculus, you would find in question 8, 9, and 10. All right, so it's almost a full paper. Only two things are missing. All right, without wasting of time, let's quickly get the ball rolling. I'm sure question 1.1 is a complete walk away or walk over for everyone. So 1.1.1, x plus 2, x minus 1. There is no need to expand this again. Some learners still want to say x times x and FOIL. No, you are wasting time. Each of these brackets should actually be equal to 0. And x equals to minus 2 or x equals to 1. You don't have time to waste there. 1.1.1, 2 marks. 1.1.2, grade 11, x squared minus x equals to 5. Immediately you see that you have to change to 2 decimal places. Quickly use your quadratic. But the important thing is this has to be written in standard form first. Without writing it in standard form, you are not going anywhere. All right, so I know my formula as x equals to minus b plus or minus square root of b squared minus 4ac over 2a. All right, please show your substitution. There is a mark for that. My b is negative 1 plus or minus square root of negative 1 squared minus 4. My a is 1 and my c is negative 5 over 2. My a is 1. I hope we are okay with my values. My a is 1, my b is negative 1, and my c is negative 5. If you plug this into your calculator, do you want to share your answers with me quickly? Plug that into your calculator. We should have 2 answers. Share your answers with me as fast as possible. I'm waiting for those answers. Two, 2.79 and negative 1.79. Do we agree? I need a seconder for those answers. I need this answer seconded. All right. Okay. Answer seconded. So we have x equals to 2.79 or negative 1.79. Did I pick those answers well? All right. Good. 1.1.3. So these are giveaway marks. These are mark boosters. And you are not allowed to make any mistake. Remember, your substitution gets a mark. Let me try to go back there and put the ticks. It's 4 marks. 1 mark for standard form. 1 mark for showing that substitution. 3 and 4 for your answers. So it's important to see where those ticks are. All right, so you get a mark. A lot of learners do it on the calculator and do not write it down. You lose that one important mark. All right, 1.3. Okay. On this one, it is important to know that you need to isolate your square root before you even begin. That's the whole idea. Isolate the square root. When I say isolate the square root, make it stand alone. All right. And the best way to do that is to move things around. Look, I can move this because I don't want a negative. All right. It's always easier to eradicate that negative. I can move this whole thing to the right hand side and then bring my 7. All right. Root 5 plus x. So I've done the first job, which is to isolate. All right. I've done the first job, which is to isolate. Now, my second job is to get rid of the square root. And how do I do that? Square both sides. Okay, so I'm going to square that and square that. Guys, when we square here, please don't distribute. We FOIL. All right, we are not distributing. We are foiling. Take note. Very important. We FOIL, not distribute. I'm emphasizing that because along the line, we do get learners who make such mistakes. So, how do you FOIL? X times x. I'm sure we all know that. X squared. X times 7. Or minus 7. Minus 7x times 2. You know where the 2 comes from? Not the 2 at the top. We FOIL. Alright. Now, on the right hand side, the squared and the square root will take care of each other. Then we have that. Now we can rearrange as x squared minus 14x minus x, writing it as standard form. And what do I have? X squared minus 15x plus 44 equals to 0. Find your factors. For me, I have quickly seen, because of time, I have seen 11 and 4. All right, x minus 11, x minus 4. If you are not sure of your factors, use your quadratic. There's nothing wrong with it. All right, so my answers are x equals to 11 or x equals to 4. However, people, please listen here. This is very crucial. When you do this particular question, you need to test your answer. What do I mean by testing your answer? You take your answers to the original question, not the one you squared. If you put it in the one you squared, your answer would be correct. Both solutions would be valid. But you take it back to the original. Let me show you what I mean. All right. This is what I mean. Let's grab a calculator. I'm going to throw in my value of x as 11. 11 minus the square root of 5 plus 11. All right. I get a 7. So 11 works. Now let's go try the second one. 4 minus the square root of 5 plus 4. That is not working. So it means x cannot be 4. Please take note. You need to discard that answer. So we are going to then say not applicable. So our answer is just that. For selecting the correct answer, you would have 1 mark. So this is how it's going to be marked. For expanding, 1 mark. Equals to 0 standard form, 1 mark. For your factors, 1 mark. And for selecting the correct answer, 1 mark. If you leave your answer without selection, you lose that mark. I hope we are clear. All right. I hope we are clear. The next one, inequality. Trying to save time. But if there's anywhere you feel lost, please, you know you can always take me back. But if you're fine, we just fly on. 4x squared plus 1 greater than or equal to. All right, I am going to as well quickly treat this like a quadratic, okay, by writing it in standard form. 4x squared plus, I think we can rearrange quickly. We're in grade 12 now. Already there, I get 1 mark. Now I am going to find my factors, which is basically my critical value. All right, there are so many little tricks that I can show you here. All right, let me quickly give you a few tips. When you get here, here are a few tips. From here, all right, if it is greater than 0, you will have 2 answers. Your answer will be greater than the big critical value and smaller than the small critical value. That's what your answer would be. X would be greater than the big one, and x would be smaller than the small one. Only when it is greater than 0. So in this case, it is greater than or equal to, so I'm just going to do that. That's number 1. Number 2, if it is less than 0, your answer would be like this. The small critical value and the big critical value. These are little secrets that you can use. It works all the time. If it is less than, then you have less than, less than. If it is greater than, then you have greater than and less than. But the question now is, what are our critical values? All right, we can factorize this one, okay? If you know how to use your factors, all good. But if you don't know, you should know. Peradventure you get confused over and over there, just use your quadratic formula. All right, for me, I've quickly seen this. I know that is 4x squared, so I'm going to have 4x, and then I'll have x there. All right, but I need to get 1 at the end of the day. 1, what are the factors of 1? It's 1 and 1. All right, now check. It is positive 1. How do I get positive 1? Knowing that there's a minus in between here. This has to be minus, and that has to be minus. I'm sure we know all of those little tricks, and you can use whichever method, like I said earlier on. All right, that is very important. Now, what are my critical values? I'll try to take things slowly here. To get my critical values, I would say 4x minus 1, check, is equal to 0. 4x equals to 1. X equals to 1 over 4. That is my first critical value. Or x minus 1 equals to 0. X equals to 1. I want you to see something that I told you just now when I summarized on the right-hand side. I said, since it is greater than 0, my answer will be bigger than the big critical value and smaller than the small critical value. I can jump straight to my answer, and this is what my answer is. All right, x is greater than 1 or equal to, that's the big critical value, and x is less than or equal to 1 over 4. That's the small critical value. All right, that is the small critical value. That's just a straight way of getting the answer. However, I'm going to show you the other ways of working this out. All right, permit me to go to the next page, and we are going to confirm if these answers are correct. My critical values are 1 over 4 and 1. So look at what I'm going to do. Let's get a page there. All right, I'm going to draw a number line. I'm sure you were taught this method. The small critical value on the left and that on the right. By the way, what is my equation? This is a longer method. If you know that one in yellow, you'll be fine. 4x minus 1, x minus 1. All right, so look at what I have. 4x minus 1, x minus 1, greater than or equal to 0. Now, let's find a number on the side. That's what we normally do. Example is a 2. If I put that 2 in this bracket as x, what will I get? 4 times 2, 8. 8 minus 1, 7. 2 minus 1 would give me 1. All right. So look at my number. My answer is a 7, a positive. What that means is that any value I pick from here on the right-hand side will be positive. That's what it means. Any value you pick there will be positive. Okay. Will be positive. Just want to clean that. All right. Positive. Mathematically, I can alternate the numbers. It's a mathematical arrangement. I can alternate the signs. But just to show us, let me bring a calculator to make it fast. All right. A number in between 1 over 4 and 1. A number between 1 over 4 and 1, I'll be covering that. A number between 1 over 4 and 1 would be half. All right? Because that's 0.25. And that's 1. So somewhere, any number here, we can use 0.5. Let's check what we are going to have if we use a 0.5. This is just trying to go into details. I've already gotten my answer. So it is 4x minus 1. So it is 4 times 0.5, which is half. And that would give me 2 minus 1, close the bracket. And then x minus 1, 0.5, which is half, minus 1. Check your answer. My answer is negative. It means any number between 1 over 4 and 1 would give me a negative. Okay. Pick a number on the side. You could actually jump to a negative 1. If you put negative 1 here, what are we going to get? 4 times negative 4, minus 1, all right? Negative 1 minus 1 would give me negative 2. This is negative 5 times negative 2. My answer is positive. Now, this simply confirms your signs. All of these numbers we are choosing is just to get our signs. Plus, minus, plus. Now, we go back to this. What do we want to get? We want to get something greater than 0, which means it must be a positive. If I then go back to my number line, I want to get a positive from here. Or how do I go to get a positive? I've got to go in that direction to get positive, and I've got to go in that direction to get a positive. I hope my arrows make sense. Look, what I normally say is drop this inequality here. It is x. Look at that arrow, the shape of that arrow, greater than your critical value, 1. Drop that arrow there. X is less than. But remember the question, less than or greater than or equal to, we need to put that 1. And those are my answers. Do you see? It's a very long method. Or we use the graph method. I'm sure you know the graph method as well. All right, so you have that. And you have 1 over 4, and you have 1, and then you're looking for greater than 0. You know those graph method things. Look, all of those are good. However, I want to save time. Check mine. When it is greater than 0, I said it becomes, where's my highlighter? I hope it makes sense, guys. When it is greater than 0, check. It will be greater than the big critical value and smaller than the small critical value. If it is less than 0, then it is less than. My small critical value on the left, my big critical value on the right. I hope it's okay, everyone. I hope we are then good to move forward. Can I get your responses? Are you okay so far? Question 1. Please check. Please let me know. We're good. So these marks are marks we are not going to give away for any reason. No mistakes. Non-Kuleko, this is just inequalities. This is grade 10. It's question 1. We've not done any grade 12 work. We're solving for x, non-Kuleko. You don't know how to do inequalities? Do you know how to do inequalities? Solving for x when we have inequalities, dealing with critical values. Talk to me quickly. While I'm waiting to read from you, let me give you some quick rules that can guide you. Number 1, simplify and write as standard form. I'm sure you know what I mean by standard form. Ax squared. So you simplify. All right. Number 2, if you multiply or divide by a negative, the inequality sign changes. For example, if I have negative, I'm just writing an example here. Because I don't want to work with that negative, I am going to multiply across by negative. So this becomes that, and that changes. Take note of that. Once I multiply by by a negative, my inequality sign changes. Take note of what I did. I multiplied by negative. Good, you know how to. Lovely. Multiplied by negative and my inequality. That's the only time your inequality sign should change. Find your critical value. And remember, 3a. If it is greater than 0, then x is smaller, less than, means small. Small critical value. And x is greater, big. Greater, big. And b, if it is less than 0, then you have less than, small critical value, and your big critical value. You can take a screenshot of that for us to save time. I think if you follow what I just wrote, those 3 steps, you will be fine. You will be okay. Moving forward. All right, this looks like playing around with a lot of algebra. Given that P equals to that, simplify P and show. Let's see, what are they up to here? What is this guy, examiner, up to? The first thing I notice is, guys, there is no x in my answer. That's the first thing I notice. So I've got to get rid of the x. Oh, wait. Laws of exponents. I am going to change my exponent just so that we see. All right. A to the power negative x times a to the power 2. That's what that means. Remember, when your bases are equal, what do? You add the exponent. So we are reversing. Minus x plus 2. That's it there. Minus x plus 2. All right. And because it's a plus, we multiply. If it was a minus, then we divide. I hope that makes sense. Now, what do I have? It's a minus 16a to the power negative x. Okay, let's see where that would lead us. Over 8. I need to get rid of anything x plus 4. Okay, look at this as well. These I can also break down as 4 times a to the power negative x times a to the power negative 1. I hope we're good. This is actually grade 10 work as well. Let's see. What's common? I'm going to circle that. Let's make it thinner just to show something here. All right, that is there. Okay, that is also there. It's actually common across. All right, it's common. Oh, so we can factor out what is common. So what will I have left on that side? A squared minus 16. Because I factor out my a to the power negative x. What's common here? A to the power negative x. There's a 1 there, guys. Please, very important. Plus 4a to the power negative 1. Ah, we're getting somewhere. We're getting somewhere. We've already taken out anything that has to do with x. So let's go ahead and simplify further. I see something here that we call dots. Difference of two squares. A squared minus 16 can be written as a squared minus 4 squared over, let's simplify the denominator. It can be written as 1 over 4 over a. It is only the a that has exponent of negative 1. Please take note. Not the 4. The only one that has an exponent of negative 1 is the a. So it goes down. I'm sure you still remember now your difference of two squares. A squared minus b squared would be equal to what? A plus b and a minus b. I love this examiner. This examiner is making sure that you didn't get to grade 12 by a computer error. The admin made a mistake and put your name in grade 12. No. This examiner is really testing that do you know your worth being in grade 12? All right. Over. We need to find the LCT. This is over 1. This is what I'm saying the examiner wants to make sure. A divided by 1 is A. Times 1, A. A divided by A is 1. Times 4. So this examiner, I love this examiner. Checking that, are you worthy of grade 12? P is A minus 4, A plus 4. Let me do this to make it easy for us. So what do we have? A minus 4, A plus 4 times A over A plus 4. So what is that? A multiplied by A minus 4. Awesome. And that's it. That is your 1.2.1. We got what the examiner wanted. So it's much of algebra simplification, difference of two squares, finding your LCD. Very important basic maths concept. I hope this makes sense. Anywhere you're lost, please let me know quickly. I know we're not so much used to this. We want to focus on the difficult things, calculus and whatnot, and we lose the marks here. This is foundational. Can I get your responses, everybody? I need your responses here. This is very foundational, and in case you've forgotten some of the steps, we've been able to remind you of what to do. Beautiful. Thank you. I know this is my distinction class. I'm expecting everyone in this group to get me distinction for maths. All right. Hence, look, the examiner said hence, guys. Once you see the word hence, start from where you stopped. That's what we're saying. Don't start from the beginning. Hence, solve for P. Oh, that's straightforward. I can even squeeze it here. Solve for P. Solve for P equals to 0. Oh, so 0 equals to A. Oh, so it's either A equals to 0 or A equals to 4. I don't know if we are on the same page with the word hence. A equals to 0 or A equals to 4. Hence, solve. Beautiful. Beautiful. So that's my 6 marks there. Lovely. 5 marks. Simultaneous equation. Wait, I think there is a question missing. Right. There is a question missing. I might have just a second. One 1.2, 1.4. Where is my 1.3? Carmel, I should show marks for the 2 previous questions. All right, we have 4 marks. Where will our 4 marks be? Let's use what color? Let's use a yellow one. All right, for factorizing, you get 1 mark there. So it's important that you are able to factorize. All right. Now, for simplification, you should get another mark. All right. And for bringing in your difference of 2 squares, the 3rd mark, and simplification, and the 4th there. And the last 1.2.2, you should just have those 2 marks. Are we okay now? All right. I just need to find 1.3. I need to quickly get 1.3. Let me quickly check what I sent to you for 1.3, because I see this is 1.4. $1.3. All right. Yeah, okay. It says that given that we have a squared, x squared, plus abx plus b squared equals to 0. All right, so this is what we have. Oh, it's a quadratic. It says show that, just trying to quickly, all right, show that for all values of a and b would have non-real. Okay, beautiful. This is talking about nature of roots. All right, nature of roots. Okay, so if the question says show that for all values of a and b, the roots are going to be unreal. All right, for all values, show that for all values of A and B, the roots are unreal. Quickly, what does it mean when we say the roots are not real? It simply means that our discriminant must be less than 0. And what's our discriminant? B squared minus 4AC. Now, what is our B? Quickly, I'm going to circle my ABC. A is always the square root of x squared, the highest exponent there. B is the square root of x, and C is my constant value. Okay, so what is my B? My B is AB. All right, don't be confused with the letters. Look at the characteristics of those letters, the coefficient of x. That's my B. Let me write it here. This is A, this is B, and that is C. All right, minus 4. What is my A? A squared. What is my C? B squared. Okay, interesting. What will this give us? A, B. Let me see. I see a way to simplify this. All right. I hope it makes sense. A squared times B squared will be AB squared. And I see these are like terms, guys. These terms are, so this is basically saying there's a 1 there. And what will this give you? Negative, no, I'm wrong with my equal sign. Negative 3 AB squared. Negative 3 AB squared. Hold on, there's something I'm doing which is wrong. That. Okay. So this is what we want to prove, guys. If you can prove that your discriminant is less than 0, then we will be fine. So this is my discriminant, and my discriminant. So my discriminant is minus 3AB squared. That is my discriminant. The question now is minus 3AB squared less than 0? Is minus 3AB squared less than 0? That's the question. Check this. I want to quickly show you the properties of numbers. All squared numbers, check this. All squared numbers are greater than 0. Take any number and square it. It will be greater than 0, even if the number is a negative. All squared numbers are greater than 0. But hold on, I am multiplying that number by negative 3. So I'm simply saying, look, AB squared, because I'm squaring it, would be greater than 0. However, or let's say but, negative 3, I am multiplying a positive number by negative, will always be less than 0 for all values of A and B, no matter what it is, because I am multiplying by negative. Therefore, since our discriminant is less than 0, the roots are unreal. We need to make that conclusion. The roots are unreal. I don't know if this is okay, guys. Unreal. I'll give you a summary again for this. Unreal roots. Remember, there are 3 types of root. I'm going to give you a 2-minute crash course on nature of roots now, because we don't know where the examiner would be coming from in terms of questions. All right, so you may take a screenshot of this while I give you a quick crash course on nature of roots. Okay. Number 1. Okay, first understand that your discriminant is b squared minus 4ac. All right. Our roots could either be real. Let me use arrows. Our roots could either be real or unreal. But when the roots are real, they could be equal or non-equal, but they are still real. Okay? Now, when they are real, our discriminant is greater than 0. But when or greater than or equal to, because I'm combining. All right? Now, if we split it, when your discriminant is equal to 0, your roots are real. When your discriminant is greater than 0, they are real and not equal. For example, the question we did in 1.1.2, yes, our second question, we had two answers, 2,79 and negative 1,79. Those numbers are not equal, yet they are real. And here, less than 0. And quickly, what will your graph look like here? It's a quadratic. I'm just going to show you what your graph would look like. If they are equal, look at what happens. My graph is going to turn right on the x-axis. All right. It's going to turn right on the x-axis. It turns right there. Take note. It turns right on the x. There. The main character is there. Equal roots. Non-equal, the one we are used to. Two values that are not equal. Two values that are not equal. Unreal, this thing is going to be floating. It will not touch the x-axis. So, I hope that crash course is okay. All right, so that is your quick nature of roots there. So please take note of the 3. Take note of the 3. Real and equal, real and non-equal, then you have unreal roots. Okay. Real and equal, real and not equal, and all of that. All right. I hope we are okay with that. I hope we're okay. Can I get your responses? Quickly, give me your responses. It's taking you back to grade 11. All right, this is taking us back to grade 11. Okay, so we can then look at the next question. Let's look at the next question. But let me quickly add something to this. For the root to be rational, all right, you'll always find this as well. They'll ask you, the roots are rational. Let me just add this. Rational roots. The discriminant must be a perfect square. And what do I mean by a perfect square? It must be something that you can solve. After solving, it must be that. There must be a squared on top there. Then we say rational roots. All right? Rational roots. Very, very important. That almost skipped my mind. The roots are real and rational. But if it is irrational roots, then the discriminant would not be a perfect square. So take note of the different properties. When the discriminant is equal to 0, real and equal. Greater than 0, real and non-equal. Less than 0, unreal. A perfect square, rational. All right? And if it is not a perfect square, then it is irrational. I hope all of this is good. Now let's move on to, I think it's simultaneous, the next one. Ooh, we're still on question 1. All right. 3 plus x equals to 2y. I think we can simply simplify by saying x is 2y minus 3. And then we substitute. Anywhere we see x, all right. So anywhere I see x, I'm going to write that 4y squared. This is nothing but algebra. 2y, this is my x, 2y minus 3 plus 7. Okay, I'm going to move with speed now because I know this is just up and flakes for us, right? Good. Remember, we are not distributing the square. I'm repeating this because of common mistakes that we always see. We do not distribute. We FOIL. I'm repeating that for emphasis. So this would give me 4y squared. 2y times 3 would give me 6 times 2 minus 12y plus 9. All right, plus 4y squared. I'm going to multiply 2y times 2y, which would give me 4y squared. And I'm going to bring it over quickly to the other side. Negative 4y squared. I hope it's making sense. 2y times negative 3 would be negative 6. Bring it over to the left, becomes positive. And then I have my 7. We change it into a standard. I see something interesting there. That should give me a 0. All right. So 4y squared 12 minus 6y, 9 minus 7 would give me positive 2. Okay, let's see. I think we should be able to find factors. Can we find factors here? Is it factorizable? Is it factorizable? Let's see. Yes, it should be. All right. So we can have 2y and y. And my factors of 1 are 1 and 1. But I want a negative 3. So that should be fine. Lovely. So 2y minus 1. Please find the method that works for you. There are so many methods. The last result is your calculator quadratic. So y equals to half or y equals to 1. But we need to solve for x. X equals to 2y minus 3. All right, I'm going to start with the half one. 2 times half would give me 1 minus 3, and that will be minus 2. And then x equals to 2y minus 3, 2 into bracket 1 minus 3, and that will give me 1. Remember, you must have 4 answers. I hope we are good. Minus 2 and minus 1 for x, minus 1 and half for y. All right, there are so many other ways. You could also use substitution elimination method if you want to, although that's a bit complex. On this particular case, I think this is the simplest way to do it. Everybody good? Are we all okay? Question 1 is done, 28 marks. Any question? We'll look at question number 2. All right, 3, 9, 17, 27. Quadratic. Okay, quickly. They told us it's quadratic, so we don't need to start wasting time. Since it's quadratic, look, the first thing is to find first difference. 9 minus 3 minus 9 would give me 8. 27 minus 17 would give me 10. Yes, it is quadratic because our second difference is 2. All right, what is the next term? It's very easy. You know, I don't know if you know this thing here. If I'm walking towards the right, what do I mean? 3 plus 6 would give me 9. Now, let me write the plus nicely so it doesn't look like a times. 3 plus 6 would give me 9. 9 plus 8 would give me 17. 17 plus 10 would give me 27. Okay, by the way, this would be 12. I hope you understand why I said 12. 6 plus 2 would give me 8, plus 2 would give me 10, plus 2 would give me 12, because that's a constant difference. All right, so 27 plus 12 would give me 39, which is what the examiner wants. Already look, that question is done. Write down the next term, 39. There is no reason to lose that mark. Determine the nth. All right, so remember, all right, 3a plus b, and that is a plus b plus c. So 2a equals to 2, a is 1, 3a plus b equals to 6. And what is our b? Our b is 3. And then a plus b plus c equals to 3. 1 plus 3 plus c. All right, c is negative 1. I hope that those are the answers we got. Guys, you see, in this kind of questions, there is no reason to lose such marks. Remember, our formula is an squared plus bn plus c. What is our a? 1. So which is n squared? What is our b? Plus 3n. And what is our c? Negative 1. All right. Negative 1. Okay. All right. I hope we are okay. Now let's find 2.3. Let's find 2.3. What is the value of the first term of the sequence? Okay, these questions. The first term of the sequence that is greater than 269. All right? No, Sophie. Don't use x. There is no x here. We're using n because n is number of terms. All right, so it's not okay to use x. We are sticking to n, the number of terms. Okay. All right, so the examiner says, what is the value of the sequence that is greater? Just interpret the question. It means there is a term, Tn, that should be greater than 269. There is a term Tn that should be great. Sophie, are you okay with my answer? Just answered your question. I need to know. All right, remember inequalities again. So n squared plus 3n minus 270. Okay, so here we need to find factors. All right, lovely. We need to find factors. Two numbers that when I multiply would give me 270 when I add. All right, if you're finding a challenge with this, you can work around your quadratic, but if you know how to find factors, but to save time, you can work around that. Okay. I'm just trying something crazy here. All right, 270, I have 333. 9 and 3, okay, it will not work for me with a 10. Okay, just don't worry about what I'm doing. I know it's crazy. 9, 333, all right. What is this? 10 times 27, but that's too far. 332, 18. 332, 18 times 15. Yes, got my answer. 18 and 15. Somebody says, how are you doing that? Okay. 18 and 15. N plus 18. N minus 15. All right. So it's either n plus 18, all right, greater than 0, or n minus 15. All right, so it means n should be greater than negative 19, or n should be less than 15. Let's interpret this. Okay, this one is not applicable. Our n should always be greater than 0. But we are now saying n should be, oh, why did I change my inequality? Sorry. N should be greater than 15. The question says, what is the value of the first term? The value of the first term greater than 269. And we said n should be greater than 15. All right? Oh, sorry, Sophie. Thank you. 18. N should be greater than 15. What is the first integer greater than 15? That's what we're going to ask ourselves. The first integer greater than 15 is 16. All right? So that means n is 16. Interpret the answer. N should be greater than 15. The first integer after 15 is 16. So it is the 16th term. But the examiner says, what is the value? So we need to calculate T16. And T16 will be 16 squared plus 3n, 3 times 16, minus 1. That needs to be done. I'm just squeezing that in because that's the question on this page. And I hope it, guys, I hope it makes 16 because n has to be greater. So we look for 303. The first term of the sequence is the 16th term. All right. The first term of the sequence is the 16th term. Let's mark this. It's 4 marks. How do we mark the whole of this? Okay. The first one was 1 mark. Good. Second one was 4 marks. A, B, C, and Tn. Okay. Now the third one is 4 marks as well. You get by interpretation 1 mark. By changing to standard form, every time you change to standard form, you always get a mark. For the factors again, 1 mark. And for concluding that it is T16, you get your first mark. All right. What is the first term? It is the 16th term. All right, everybody okay? Are we okay with that? Are we okay, everybody? We're done with question 2. I hope you learned one or two things. Can I move on? Look, a question that the examiner can throw at you here, I think I've discussed this with you as well when we're doing some revision, I don't remember, is to find the maximum or the minimum term. I did explain this, of a quadratic. All right, in this case, it's not applicable. It's this number keeps increasing, but there are some quadratics. This is a parabola. All right, now Sophie was saying something earlier on, and I'm going to bring that in. This is a parabola where we say y equals to ax squared plus bx plus c. A possible pattern is this. That's a quadratic. And these quadratics have what you call minimum and maximum. Oh, by the way, these are called turning points. So when the examiner says find the maximum or minimum, it simply tells you to find the turning point. And how do you find that? Remember, this one is x equals to minus b over 2a. You do the same. But this time around, you're not saying x. You're saying the n is that. Whatever you get here would be n. And please note that n has to be greater than 0. All right, and it's an integer. N must be greater than 0, and n is an element of integers. So your minimum or maximum would be that. I have a question. Let me see if I can quickly do that question. There's a number pattern I did sometime, and if you check your Google under number patterns, I do have that. But let me show you a very quick question, 2 minutes here, on a question where this was asked. Look at this pattern. I remember the pattern very well because it's very unique. All right. So here I have what, 17. Here I have 15. So it was going down. Okay. So 2a is equal to negative 2. A is negative 1. 3a plus b is 17. All right. And b is 20. A plus b plus c equals to 0. What is my a? Negative 1 plus 20 plus c. All right. C is 20 minus 1, 19. We move it over. I hope I remember the values. Now, what is my Tn? An squared plus bn. Now, the question is, what is the maximum number or maximum value of this pattern? All right, you would see this is a negative here. All right, parabola. The graph actually looks like that. That's why the examiner is talking about maximum. If the graph looks like this, then they'll be talking about minimum. So this is bringing functions. All I need to do is to say n equals to minus b over 2a. Minus b is 20 and 1. Oh, it means T10 is the maximum. T10 is the maximum. And you can prove it. Let's quickly prove it. How do I prove it? Let's find T9. Let's find T10. And let's find T11. I'm actually jumping into functions now. T9. I'm going to throw in my calculator. It's negative 9 squared plus, let's just do the math. 20 times 9, 180 minus 19. This is 80. I can tell you that this one will be 80. But let's check. I'll tell you why I'm saying that is 80. It's basic functions. 11 squared plus 20 times 11 will be 220 minus 19. 80. Told you. And T10 would be negative 10 squared plus 20. What is my n again? My n is 10, so 200 minus 19. 81. Check something there. Do you see the number? T9 is 80. T10, 81. Basically, we are looking at a parabolic function. It is 80 here. It is 81 there. It comes back to 80. Do you know why? Your line of symmetry is here at the turning point. Anything that happens on the left is replicated on the right hand side. All right, so these are things you should be expecting in a question paper. Extended knowledge or applications of a quadratic function. Okay, can I go to question 3? Any question? Type no if there is no question. We're good. Beautiful. Beautiful. Mostly the question will tell you what is the maximum, which term is the maximum, or which term is the minimum, depending on the shape of your parabola. Which term is the maximum? Then it's the 10th term. Which term would be the minimum? Then you need to find. In this case, there's no minimum. It's a maximum term. All right. So anytime you see the word maximum or minimum, it's similar to your calculus. It is similar to your calculus. If you remember applications of calculus, when do we derive? We derive when the examiner says maximum or minimum. The first derivative will be equal to 0. If I derive this, all right, so Tn, if I derive with respect to n, I will be having, let me create an expression, deriving that with respect to n would be what? Minus 2n plus 20. I'm sure you can derive. And we said that should be equal to 0. So negative 2n make sense? So it's an application question there that the examiner is throwing right back in our faces. But we got them now. Okay? I hope that is sorted. Question number 3. Muzi, did I answer your question? All right, beautiful. Guys, I hope this revision is empowering us and getting us ready. The first two terms of an arithmetic series A and a geometric series to infinity B are the same. Okay. Write down in terms of A the third of the geometric. Wait. The third, they told us clear blunt that a geometric. Don't forget, once it's a geometric, so we need to get our ratio first. All right. R 3.1.1. R T2 over T1. which is a over negative 2. Now, what would be the third? T3 is AR squared. I hope you remember. What is my A? Negative 2. What is my R? A over negative 2 squared. And what will this be? Negative 2, let's make it simple for us, over 4. Okay? And what would that be? Negative A squared over 2. Negative A squared over 2. All right, don't let the question defeat you. Interpret the question gradually. The third of the arithmetic, 3.1.2, our D is T2 minus T1, which is A minus. Don't forget it's a double minus. All right, so T3 is A plus 2D. What is my first term? A, negative 2 plus 2, A plus 2. Simple algebra, 2A plus 4. And what will this be? 4 minus 2, so it's 2A. Yes, talk to me. Okay. I hope we're okay with those two questions. You'll be getting a mark for your ratio and final answer. Same thing here, you get a mark for your difference and then final answer. All right. So don't let the question threaten you. Take the question and interpret gradually. You know, that's the whole idea. What can I interpret from the statement given? How can I interpret the statement given? Don't let the question overwhelm you. Oh, I've seen this before. No. What is it? What principle is it that I know? And that's what you do. The sum of the first 3 terms of the arithmetic, it's a continuation. All right, it's the same as the third. Oh, good. This is what I'm saying, guys. Interpret the question. Don't be overwhelmed. It says the sum of the first 3 terms, 3.2, T1 plus T2. You see, I'm interpreting. The same, mathematically, we write equals, as the third, okay, of the geometric. Oh, so this is the arithmetic, which is A. Let me just do this. It's the same as the third. Look, once you do that, let's go simplify. What is my T1? My T1 is negative 2 plus A. What's my T3? 2A plus 2. Remember, it is the arithmetic one. Don't let it overwhelm you, guys. Once you're overwhelmed, you stop thinking. It's equal to the third of the geometric minus A squared. Done. So for A, write down an equation and determine the value of A. Write down an equation for the value of A. So let's simplify. Oh, 2 minus 2 would give me 0 there. I have 3A equals to negative A squared over 2. All right, I can simplify that. What would I have? 6A equals to that. All right. Now, it is important here that you don't just divide. Listen, this thing here, let's talk about a few algebra stuff. This thing here tells you that there are 2 answers of A. That exponent tells you that there are 2 answers of A, which is very important. So don't divide, guys. Don't divide. Is that okay? We just simplify. 6A plus a squared equals to 0. What's common? A. 6 plus a. So it's either a equals to 0 or a equals to negative 6. Very, very important. Very, very important. Please do not divide. If you divide, you are going to get one answer. I hope that makes sense. So we have our 5 marks. Let's mark and see where our answers would be. For interpreting the solution, you get 1 mark there. All right? For writing as a standard form, so take note, every time you write as a standard form, you get a mark. Are we okay? For factorizing, what are we going to get? It's 5 marks. But let's see, we have a equals to 0, or I think select the question is find value of a. Let's see which one of them is applicable, because I see that 3.3 a equals to negative 6. All right, hold on. Factors, I have that. Can my a be 0? Let's go check something. What's our ratio? 0 over 2. Just want to check something here. A cannot be 0. Do you know why a cannot be 0? Because if our a is 0, then the ratio will be 0. Do you see that here? And the ratio cannot be 0. Okay, so take note of that. So a cannot be 0, not applicable. So we get a mark there. 1, 2, 3, 4. Write down the question and determine the value of a. So a can only be negative 6. All right. For factorizing, we get 1 mark, and for the factors, we get another mark there. And for selecting, we get our final mark. I hope it makes sense, guys. A cannot be 0. If a is 0, then there's no ratio, because our ratio is a over 2. And the next question is what actually sells it out. If a equals to negative 6, do we remember our rule of convergence? Let me go to a fresh page. Do we remember our rule of convergence? Do you remember from your formula page? What is the rule of convergence, or the condition for convergence? Convergence. R must be in between negative 1 and 1. So if a equals negative 6, determine if the geometric series converge. Let's go find R. Remember, our R is, we got an expression for R. Let's go copy it. Our R is a over negative 2. Our R is a over negative 2. Is it? Yes. Okay. But we are told that a is now negative 6. So R is negative 6 over negative 2, which is what? 3. Will it converge? Determine if it converge. No. It will not converge. No, it will not converge. I hope we are on the same page. Yes? No. Go back. Let me take you back. T3 is a squared over 2. The first mark, you see the first tick there, that's our R. You good? Uncle, you good? Okay, so it will not converge. And what's the reason? R is greater than what? 1. All right, so just put there for convergence. For convergence, that must be satisfied, but R is greater than 1 because R is 3. So it will not converge. 12 marks, done. That's your number patterns, guys. And I think I've mentioned a few things. All right, I've mentioned a few things. Can we move to question number 4, functions? Oh, no, we still have number patterns. Let's quickly solve this. The sum of n terms of sequence of numbers is given by, all right, so we have the sum, Sn, remember? We're given this. I'm sure there's a little trick here that you need to remember. I did teach you that before I even go forward. Sn equals to Sn minus 1. You must not forget this. It's not on the formula page. It's an application. All right. Let's see quickly. The sum of n terms of the sequence of numbers is given as that. Nonku, you said not in term 2. All right, remember we are working with different provinces. So we have a merge of provinces here. So I'm sure it's in one of the provinces. Calculate the sum of 4.1.1. Calculate the sum. Don't forget it is the sum. So basically it is S23. And we just throw that in. You want to give me an answer for that? Give me an answer quickly. Just to make sure that we are still here. I like this revision. It's just beautiful. I want an answer. Okay, thank you. 1426. Beautiful. All right, that's so easy. You get your 3 marks there. All right, you get your 3 marks. But however, an examiner always wants, but you can just go straight. They always want people to simplify sometimes. You got 1426, but if you simplify that, let's see quickly. 5 times 23 would give you 15, 10, 11, 115 plus 9, that will give you 124. Okay. And that will then give you 1426. All right, 4.1.2. Hence, calculate the 23rd term. I'm going to bring in the formula I wrote on the board. Hence, calculate the 23rd. So basically, S23 is S22 plus, don't forget. So if you substitute n in that formula that I have, that's what we are going to get. All right, so what is my S23? We have it as 1426. What is my S22? We need to sub 22 over 2. 22. So 1426. What is 5 times 22? That will be 10. That will be 110 plus 9. That will be 119. And 119 times 11 should give us what? 1309. Am I right? Yeah, 1309. Confirm for me. 119. Yep. Please confirm. 1309 plus T23. Just confirm for me. And then my T23 would be 1426 minus 1309. And we should have 117. Okay, thank you. 117. All right. So please remember that formula there. It's not really a formula, it's just an understanding of number patterns and application. Okay. 4.2. If x is a real number, show that that cannot be a geometric. You know the key word here, guys? The key word here is the fact that they have used geometric. Once you see geometric, start thinking on the ratio side. So let's find the ratio. And how do you find ratio? T2 over T1. That should be equal to T3 over T2. Let's solve for x. All right, so it's 1, x plus 1, and x minus 3. 1, x plus 1, x minus 3. Let's find our ratio. T2 over T1, T3 over T2. So it's x plus 1 over 1, x minus 3. Okay. Let's cross multiply. Going to have x plus 1 into bracket x plus 1. All right, I'm going to just shortcut now. This will give me 2x plus 1 minus x minus 3 equals to 0. So I have x squared. 2x minus x would give me what? 1 minus 3 would give me minus 2. Do you want to solve for x? Can we factorize this? Can we factorize that? There's a mistake. Sorry. This is minus. Minus 3 there becomes plus 3 plus 4. Okay, we cannot factorize this. I don't think we can factorize. You want to factorize that for me? Find me x. Are you trying to solve? I don't see a solution here. Let me quickly show you that there's no solution. What is b squared minus 4ac? Quickly, my discriminant. My b is 1 minus 4. What is my a? 1. And what is my c? 4. All right, 1 minus 16. Since my, let's bring in nature of roots. Since my discriminant is less than 0, the roots are unreal, which means there is no solution. That is me bringing my nature of roots. All right, analysis I can't. So your calculator would give you an error. Once your calculator gives you an error, please show that x has no solution. This is one of the ways to prove it. Or you can use your quadratic. We're talking about presentation now. Minus 1 plus or minus square root of 1 squared minus 4, 1 into bracket 4 over 2a. All right. And you're going to have minus 1 plus or minus square root of negative 15 over 2, which means no real solution. So don't be scared in an exam. What you can do is to confirm using your nature of roots. And we spoke about that today as well. All right, so we have proven that it cannot be geometric because x has no solution. Great. Let's see. Functions. I love this one. I love this. And I'm going to quickly show you something here as well. There's something I've been longing to show you here. If you go through the videos that I did, you would find some important points there. I'll start from the first one. Guys, before I even look at this, let's check something. Look at this. Let's simplify this. Minus 6, I want us to simplify. Minus 6 over x minus 3 minus 1. Let's simplify this, all right? By LCD. So x minus 3 divided by x minus 3 would give me 1. 1 times that will give me negative 6. Okay, minus. I'll show you what I'm doing here. X minus 3 divided by 1. So I have x minus 3. So what am I going to have if I expand? I'll have negative 6 minus x plus 3 over x minus 3. What is 3 minus 6? So basically I'm having what? Minus x minus 3. Am I making a mistake? Minus 3 there. Alright. Minus x plus 3 over. No, there's something I'm doing wrong. There is something I'm doing wrong. X minus 3 divided by x minus 3 would give me 1. Okay, minus 6. And that would give me minus x plus 3. All right. This is giving me... Okay. Let's check something here. I want to try something here. It's fine. So, look at what we have. Can we change this? So an examiner gives you this equation and says f of x is minus x minus 3. From what I did, we all agree that this equation, I took it from minus 6 just by simplifying, right? We all agree. We simplified. Okay? This is hectic. Look at what I'm going to do here. This is minus x. Let's check something here. All right. So an examiner gives me minus x minus 3 over x minus 3. Look at what I'm going to do. I'm going to start by writing the denominator. Because there's a minus x there, I'm going to have minus. That minus comes there. Open the bracket. Repeat my denominator. It's my denominator that comes up. And add k to it. Now, this numerator and this numerator should be the same. So, minus x minus 3 is equal to, if we expand that bracket, minus x plus 3 plus k. Minus x plus x minus 3 minus 3 equals to k. So, my k equals to negative 6. Now, watch what I'm going to do. I am going to now replace this. Minus x minus 3 plus, instead of writing, remember it's k. Instead of writing my k, I'm going to change it to negative 6 over x minus 3. We are going to split this. This can be written as minus x minus 3 over x minus 3 minus 6 over x minus 3. You remember what we do? We split the numerator since we are dividing by one denominator. That goes -1 minus 6. And I can rearrange this to look like a hyperbola. Minus 6 over x minus 3 minus 1, which is we've gone back to the equation that we're given. Why do I need to show you that? I'll show you another one before I start answering this question. It's because if an examiner gives you this format, you will not, number one, you won't even know it's a hyperbola. All right? So you need to be able to see that it is an hyperbola and solve it this way. For clarity, can I quickly create two questions for you? Look at this. Just, I want to make sure you are enriched. Look at this, x minus 2 over x minus 5. Let's change it to a standard hyperbolic formula. All right, this one is positive. There's no story here. This one is very easy. I start by my denominator. Copy my denominator again. There's nothing here. Plus k. Okay? It means my numerators must be the same. All right, you see there's no minus here, so it's quite easy. So what do we have? X minus 2 equals to x, because you want to find k. X minus 2 plus 5 equals to k. 5 minus 2, k is 3. Now I'm going to replace it there. All right, so it is x minus 5. My k is positive 3 over x minus 5. Split the 2. X minus 5 over x minus 5 plus 3 over x minus 5. 1 plus 3 over x minus 5. Do you see your equation coming out? That's your hyperbolic equation now. Very important concept. What about this? What if I have this? 4x minus 10 over x minus 2. Just creating numbers now. Now, there's a bit of a difference. There's a 4 here. You see, there's a 4 in front of the x, similar to the minus. I'm going to have a 4. That 4 comes out. My denominator again, plus k. All right? My numerators must be equal. 4x minus 10 equals to 4x minus 8 plus k. So if the 4x would then go minus 10 plus 8 equals to k. 8 minus 10, k equals to negative what? 2. Let's rewrite our equation now. So it is 4x minus 2 over, so you replace your k. My k is negative 2. Once you do that, you split it. 4 into bracket x minus 2 over x minus 2 minus 2 over x minus 2. That goes 4 minus 2. All right, let's write it in our standard form. Negative 2 over x minus 2 plus 4. Talk to me. Are you okay with what I just did? Are you okay with what I just did? I'm not. It's a question. It's a format. Examiners can throw that at you. I hope it makes sense. All right. I hope it makes sense. So whatever is in front of the x, you write it down, okay, and then you repeat your denominator. Find the value of k, and then we just rewrite and manipulate. So you saw what I did with that negative there. Again, let's go back to the negative. There's a negative in front of the x. I start by that negative, rewrite my denominator, and add k. Okay, so you find your k. Because if I give it to you as minus x minus 3 over x minus 3, you will not be able to sketch the graph. Awesome. All right, so, but luckily for us, it's quite straightforward. But right now, you know what to do should you come across something like this. Okay, let's run. Let us run. Calculate the y-intercept. I think that's straightforward. What do? Our x is supposed to be 0. So y equals to minus 6. All right, y-intercept is 0. Please show that 0. Don't just do it in your head or calculator. Now you can quickly solve. Minus 6 over minus 3 would be positive 2. And 2 minus 1 would be 1. Calculate the y-intercept. I hope we are okay with my solution there. All right. Calculate the x-intercept. Y becomes 0. Please move the 1 first. All right. It's important. Multiply. What is x? 3 minus 6. Okay, so we have our x-intercept and our y-intercept. Sketch the graph. Show the asymptotes. I hope you know what to do here. That's very straightforward. Let us sketch the graph. Can I just sketch the graph on the side instead of moving to another page? So the first thing is to show my asymptotes. And we know the horizontal and vertical asymptote. X equals to 3 would be my vertical asymptote. You know where the 3 came from? Our P and our Q, right? That would be 3. Just in case you don't know where it came from, guys, asymptote means where this graph will be undefined. And for this to be undefined, the denominator has to be 0. So x equals to 3 and y equals to negative 1. Those are my asymptotes, my P and Q. Y equals to negative 1. So those are the things we draw first. Negative 1. Number 2, our intercepts. Y equals to positive 1. That means your graph would be passing through that point. And so let's show that 1. And x equals to negative 3. Your graph will be passing through that point. All right. Once you have that, you can then sketch your graph. Passes through those 2 points, doesn't touch the asymptote, but you know that this graph has to have the other end. And that is my graph, guys. Are we okay with this? Is it okay? Show the asymptotes and the intercept with the axis. Show the asymptote. Let me also do something here. I need your response. Are you okay with this? I want to quickly do something else before I answer 5.1.4. Before I answer 5.1.4, axis of symmetry, quickly. Ooh, I'm telling you, with this lesson, you are ready for finals for maths. Minus, okay, your axis of symmetry, guys, usually it is this. This is your equation. This is basically your axis of symmetry. That's your axis of symmetry. So, and there are 2 axes of symmetry. The one with the positive gradient and the one with the negative gradient. Let me quickly do it on the first page. Y equals to minus 6 over x minus 3. Y equals to over x minus 3. All right, so axis of symmetry. This, like I said earlier on, I don't know how you were taught, but that's your axis. So y equals to 1. Y equals to. Second one, axis of symmetry with negative gradient. It's going to be y equals to, because it's negative gradient, negative x minus 3 minus 1 minus x plus 3 minus 1. 1 minus 3 minus 2. Those are your axes of symmetry. Right? Those are your axes of symmetry. I hope it makes sense, people. I hope it makes sense. 5.1.4. For which values of x is f of x greater than 0? When they say f of x, guys, they are simply referring to your y value. I'm sure you know that. When they say f of x, they are simply referring to our y value. Where is our y value greater than 0? Anywhere where the graph is above the y-axis. Where is it greater than 0? Look, let me do this. I hope this would make sense. Your y value here is negative, 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 negative. Your y value here is 0. Positive, 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 positive. Your y value here is negative, negative, negative. I'll go back just now. Let me finish this. So for f of x to be greater than 0, we are looking for where y is positive. And where is that? That is between negative 3 and 3. All right, between. I like to do this. Between negative 3 and 3. Whenever you use between, guys, you can use this inequality. Between negative 3 and 3, and x is an element of real numbers. X is an element of negative 3 to 3. Either of the two ways, that's how to represent our answer. It cannot just be greater than negative 3, because immediately after 3, what is the value? It's a negative. Your graph becomes a negative. Just after 3, your graph becomes a negative. And you can try it, you can put a 4 in your equation, you would see that you would get a negative. Nonku, is this what you want? Nduduzi, did I make myself clear there? It's not just greater than negative 3, it's between negative 3 and 3, because after 3, it becomes negative. Nonku? Huh?
That was the question.
For which values of x is f of x greater than 0? Are we okay? All right. It's been a while you guys spoke to me whether you're okay or not. Are you okay here? Everybody okay? It's just revision, so it's things we know. We're just putting things into perspective here. I'm sure you are also getting one or two things that you are that will give us our distinctions. Let's see the next question. Are we done with that? Oh, calculate the average gradient of f. All right. Yes?
Sir, please go to the last slide.
Let's say, which slide? This one? Okay, there you go. You're welcome. All right, find the gradient. How do we calculate gradient, guys? If you remember when I did calculus with you, I told you that, all right, gradient is basically changing y over changing as y2 minus y1 over x2 minus x1. And written as f of x2 minus f of x1. So I can therefore say my gradient is f of negative 2 minus f of 0 over the x values. Take note of that. Function notation. F of minus 2 over f of 0. What do we mean by f of minus 2? We substitute. So let's find f of minus 2. It is going to be minus 6 over minus 2. All right, what would that be? Is it minus 6 though? Yeah, it's minus 6. What will this be? Minus 6 over minus 5. That is 6 over 5. Minus 1. That is 1 over 5. 6 over 5 minus 5 over 5. Yes, 1 over 5. And already f of 0. Do you remember we have that? That's our y-intercept. X is 0. We did that. So what's our gradient? 1 over 5 minus 1 over minus 2 minus 0. All right, if you use your calculator here, which I believe you don't need, what will your answer be? Do you need a calculator here? 1 over 5 minus 1 would give us 4 over 5, divided by negative 2, which is basically times 1 over negative 2. Minus 4 over 5. All right, so my answer is, what would that be? 2 over 5, which makes sense. Can I quickly do something here with you? 2 over 5. Can I quickly do something? I want to do something here. Are we okay here? I want to do something. For which values? Check this. Of x will don't forget what your f of x is. Can I get your response? I want to quickly check something here. Who knows what to do here? Who knows what to, you know how to deal with this? Can I quickly get your response? Okay, my question is, do you know what to do? Yes or no? Please, everybody respond.
Sir,
Hi.
isn't f prime of x is equals to m?
The derivative, yes.
So the question means that for each value x with the gradient equals this.
Yes. All right, Nduduzi has just simply explained what I need us to do. All right, don't forget, guys, that this thing here, from calculus, we know it's gradient, and that's where I started my calculus from. So if you look at the graph that we have, this you solve using the graph. If you look at the graph that we have, we had something like this. Look at what I'm going to do. There's actually no answer to this question. Now, this means gradient. Guys, if I need to calculate gradient of this graph, do you notice the gradient of this graph? It was positive. That's what reminded me of this question. If I want to get the gradient of this graph, because first derivative means gradient, do you notice that my gradient will be positive of any 2 points on this graph? That's why we had a positive answer. All right? Gradient is the shortest distance between 2 points. So I created 2 points. It means for this particular function, guys, the gradient will always be greater than 0. So there is no solution of x. I don't know if that makes sense. Don't derive. At this stage of our mathematics and calculus, we are not going to be able to derive this. This we will derive when we get to varsity using all kinds of method, like your quotient rule, your chain rule. That we will do next year. So basically, right now, we are just applying. So the examiner says, for which value will the gradient of a hyperbola? Look at this graph. The gradient of this hyperbola will always be positive. So the gradient will always be greater than 0. No solution for x. But should the examiner have said this? Then we will have said x is an element of, or from negative to infinity. Let me do this. It will have been from negative infinity to positive infinity, but x cannot be equal to, remember everything we do in this graph, f cannot be equal to 3. Why? That's my asymptote. There's no gradients, because the graph does not exist. No. Greater than. So the gradient of this graph remains positive across the board, but not at negative 3, because the graph does not exist at 3. The graph does not exist at 3. I hope this makes sense, people. I'm sure you did this in class. So these are applications of derivative that I'm bringing back into functions. F prime of x means gradient. Are we okay? We need to finish up now. Can I move on? Can I move on? Did we get that interpretation? So it means gradient. Quickly. It means gradient. Can I get your responses? If you're not okay, let me know. It's important, an important concept that we need to get. Are we okay? I want all yeses and all no's if we are lost. Okay, thank you for those answers. I'm glad. All right. I think I have one more question on that graph thing. Let's look at this one. I love this question. This question is not very common, but it's a quick test if you understand what function is. Sketch the graph. And somebody says, how do I sketch a graph when there are no numbers? Yes. The question is, do you know the attributes of those things? And we are given some properties. Okay, let's go check the properties. Number one, I'm going to interpret them one by one. Ax squared plus bx plus c. All right. This tells me, number one, it is a parabola. Okay. Now, if a is less than 0, the first thing I know is that it is a sad face. You know what I mean by sad face, right? If b is less than 0, very interesting. Very interesting. It means that the turning point is negative. I'm not sure many of us know that. Let me show you that, what I mean. How do I get my turning point? X equals to minus b over 2a. But check something. B is negative, right? They said b is less than 0, so it is negative. Okay. Over 2. My a is also negative. I hope that makes sense, guys. First, my b is less than 0, which means it's a negative value. My a is also less than 0, it's a negative value. So my answer is actually positive there, divided by negative. So it means, guys, that my turning point is negative. That's very important. When I sketch the graph, you'll be able to see. Okay, my turning point there has to be on the negative side in terms of x. What about c less than 0? What does it mean? That's my y what? Intercept. Okay? And finally, they said ax plus bx plus c, ax squared plus bx plus c equals to 0 has one solution. What does that mean? It touches the graph once, touches the x-axis once. Let's sketch. Applying all of these things that we have. Number one, it's a sad face. Number two, my turning point is on the left because we got a negative. Number three, my y-intercept is negative. Number four, it has one solution. It touches the graph, the x-axis, just once. There's only one possible way to do that. And that's your graph. That is the implication of your graph. I don't know if we are okay here. So we've got to interpret every of those things one by one. The sad face, the turning point is negative. So you saw how I did my turning point. If b was greater than 0, what would my answer, my graph would have been on the right hand side? So let me, here, b is less than 0, a is also less than 0. Should my b have been greater than 0, check this, and a less than 0? All right? Negative a, my answer is positive. So my graph would have been like this. This is b greater than 0. You don't need to cram it, just work it out the way I did. Don't try to cram it at all. It's not how many things are you going to cram? Apply it. All right. And this one here means only one solution. That's your C there. And these are your turning points. This is how I got my turning points. Okay, I hope we are okay. And the shape, definitely a less than 0. Sad face. Lovely interpretation here. Can I move on? I think we still have inverse to deal with. Can I move on? We have inverse function to deal with. We have really learned a lot into this lesson. It's been amazing, amazing, amazing. Whew. We have all of this. I don't think I'll finish this. After this, I'll just run to application. All right, let's look at this. Interesting. In the diagram below, f of x is 2 to the power x, which is exponential, and the inverse are given. All right, a and c are points in f, b is the inverse, okay, cb and AB are perpendicular. Lovely. All right, just interpreted the whole question now. And the first question is what? Write down the equation of the inverse. Okay, I'm sure we can do that. If f of x, all right, so y equals to 2, what do we do for inverse? Anywhere we see x, we write y, and anywhere we see y, we write x, and then we solve. Or we simplify rather, making y the change of subject. I'm sure we all did this. Look, the 2 is a base here. All right? It's going to come here and become a base. And that's your answer. We introduce logs. This again we will do when we get to financial maths. So to solve an exponent, this is what your calculator does. It uses logs. To solve an exponent, we use logs. Everybody okay? So the 2 is a base. So the idea is the 2 is a base. When it comes here, it must also remain as a base. How many marks was that? 2. Beautiful. Find the length of AB. Interesting. For 5 marks. Oh, I see what to do. All right, find the length of AB. Look at this interesting concept. Find the length of AB. I can get the length of AB if I know the x values. But both values for y are 3. So let's work out on our f of x. Y equals to 2 to the power x. I do know my y value for a, all right? Because a is on f of x, remember. So we're working out a. How do you get the x? We said if the variable unknown is the exponent, we use logs. So 2 is a base, it remains as a base. Okay, you can use a calculator to get the value of x. Do you want to give me the value of x quickly there? What is your value of x? I want to check if we know how to use our calculator. .58. Anybody confirming that answer? .58. Do I have somebody else confirming that answer is correct? So you go to your calculator. Let's quickly show in case someone gets the slip and they don't know what to do. It's the first button on the right there. All right, so the 2 goes down and the 3 goes there. 1,58. Beautiful. Thank you. Okay, I hope we're good with that. Now the next one, we want the y value. Oh no, my y is 3. How do we get x? That becomes 2 to the power 3. It's a log principle. X equals to 8. So the 2 comes there. Remember I said it's a base. When it gets to this side as well, it must remain as a base. So my x is 8. So what is the distance AB? So basically we're saying here we got 8. Here we got 1,56. Oh, that's now easy. AB is equal to 8 minus 1,56. And that will be what? 9 minus 5 would be 4, 4. 6,44 units. units. Can I please get your responses if you are okay? We need to round up now or soon. Are we okay? Are we okay? Hello, everybody. Are we okay? I think I'll stop this session on question 6. Okay, I'll stop this session on question 6. When are we writing maths? Let me check. When are we writing maths? Monday, Tuesday. Well, today's Monday already. Tuesday, Wednesday, Thursday, Friday. Anybody writing before Wednesday? Just type in the date. Thursday, Lesedi. Okay. I need response. Gobind, when are you writing? Sandy. All right. Oh, 7th of July. You still have enough time there. Okay. Tutuzi, also on Thursday. Okay. Thursday as well. All right. Okay. No problem. All right. Let's finish question 6 today. You can then go through. Probably on Wednesday, we then look at calculus and its applications, but at least these ones you know you have perfected. Calculate the length of AB. Let's check the length of AB. Let me crop this, the length of AB. This examiner is just extra clever, like what I did. Calculate the length of AB. No, the next question, was it AB? Calculate we've done AB. Calculate the length of CB. All right, let's go back to our graph. Now, you would notice that at CB that we are looking for now, let me erase this. We know our X value as 8. Just the same way, the length of CB, it's now vertical, so we are looking for Y values now. Let's look for the Y value of C. It's actually on f of x, 2 to the power 8, because my x is 8. Okay, my x is 8. And what about B? Oh, B is 3. By the way, the Y value is, so I don't know if it makes sense. CB is 2 to the power 8 minus 3. 2 to the power 8, 3. Does that make sense? 2 to the power 8 is 256. So my answer is 200. I know some of you would have thought this answer is too big, and then you start doubting yourself. No. my x value is 8. That's what we're saying. And C is, if we look at CB, it talks about a vertical line. And once I refer to vertical, I am referring to y values. So the value of C minus the value of B. And B is on my inverse function. Okay, let's finish this. Calculate the length of CB. Okay, that we've done. The domain of the inverse. Oh, easy stuff. The domain of the inverse. Okay, let me quickly help you with something here that I feel is also important. Domain. And range. All right. The domain of f, of f of x, not derivative, is the range of the inverse. Take note of that. And vice versa. That's one lovely way to understand inverse function. So if let's try something here. I'm going to try something with you, and I want to believe that I would help you to make sense. All right, look at these two graphs. I want us to just walk around 5 minutes or so, or less than, and we're done here. But I want you to quickly understand domain and range in terms of this, because I love applications, if you've noticed. All right. So look at my f. What can you tell me about my f? The domain. All right. X is greater than 0, because my graph starts from negative infinity. No. Not that. It's from negative infinity, and it continues to positive what? Infinity, because the graph is going to go on. All right, so my x is an element of negative infinity to positive infinity. That's my domain. And for range, let me use red here so that we would see that I'm talking about this. Do you notice my range talks about my y values, and they are above the x-axis? Y is greater than 0. Now, look at what I'm going to do. I'm just going to change everything I've done there. Remember, when we talk about inverse, x becomes y, and y becomes x. I'm just going to do the same exact thing there. So where I have my domain x, I'm just going to write y. Y is an element of negative infinity to positive infinity. And y greater than 0, x greater than 0. I have just inversed it, the domain and the range. The domain and the range. Don't forget, when you do this, x is an element of real numbers. Y is an element of real numbers. Okay. Talk to me. Are we okay with what we did so far? Question 1 to 6. Question 1 to 6. We are only left with calculus.